Okay, so we've discussed that average gradient is where we have a nonlinear function and we have a straight line passing through 2 points on that function, just like we pretty much have on our screen at the moment. And to calculate the gradient between those two very separate points of A and B, we did our change in y over our change in x. Okay, now we start considering the following. If I were to take point B, let's make it in red. If I were to take point A and point B, and the idea is that they're going to start moving closer and closer and closer towards each other. The goal being that I'm actually wanting to work to the point that where point A and point B are essentially no longer two separate points, but they become 1 point. Okay, that's what we're working towards here. So this gap between x and x plus h, remember was a distance of h units, okay? So if I started moving point B closer to point A, do you agree that that distance of h is now going to end up getting a bit smaller? And if B moves even closer to A, that distance of h moves even smaller. And as B and A move closer and closer and closer towards each other, that distance of h is getting closer and closer and closer towards 0. It's going to land up eventually becoming nothing, okay? Now, the idea would be this. If I were to take a microscope over point A and point B, and I moved it, point A and point B, half a unit closer, and then half a unit of that half a unit closer, and closer, and closer, and closer. Technically speaking, if we kept magnifying it, point A and point B will never actually touch, okay? Theoretically speaking, they will move infinitely close towards each other, all right? And the gap of h will then move infinitely close towards being nothing, okay, well, being 0. And it's at that point where point A and point B have moved so infinitely close towards each other that they look like they're 1 point. Then we no longer have this line passing through two separate points. As you can see at the moment, the line passes through two separate points. But as point A and point B move so close towards each other, let's just get a line here. They move so close towards each other that they look like they become 1 point. Do you spot now that this line, let's get it nice and exact on there, is no longer touching you're passing through your graph at two separate points, but it's very specifically touching your graph at 1 point. So this line over here then actually starts becoming called, it has a special name, and it's called a tangent. Okay, so a tangent is a line that touches a function at one specific spot. Okay, now how do I work out the gradient of that tangent? Okay, well, let's go with this. We knew that average gradient was change in y over change in x. So let's quickly actually write that. So we know that average gradient was equal to my f of x plus h minus f of x, that was your y1 minus y2, over h, which we got by taking x1 minus x2. Okay, so that was if it was at 2 points. Now, as we start moving as this distance of h closer and closer and closer towards 0, so your point A and point B move closer and closer and closer towards being 1 point. So what we're then going to do is this. We're going to say that there is a limit. And your limit is where your distance of h is tending towards 0. Because at the point where your distance of h is as 0 as it looks to the naked eye, point A and point B are as 1 point as they look to the naked eye. So at the point where your limit has tended towards 0, your f of x plus h, so in other words, the gradient between point A and point B is now actually at 1 point, okay? So it becomes the gradient at that 1 point. All right. Now so this limit is a very important concept here, because essentially it's the only difference really between our average gradient and my gradient of a tangent, okay? But it's a very important one, because by adding in that limit tends towards 0, we've gone from having two separate points to now working with the gradient at 1 point. Now the gradient at 1 point in calculus has a very special name, all right? The gradient of a tangent. Okay, and just remember, a tangent is a line that touches a graph at one point. So the gradient of a tangent is equal to what we call the derivative. Okay, so in calculus, you're going to hear this word derivative a lot, okay? And it's so important that you remember to just keep going back to the original definition of what is a derivative. It's the gradient of your tangent. Another way I could phrase that is I could say it's the rate of change at one point, okay? And what we normally do is we give the derivative a special notation. We don't just call it f of x, we call it f prime x. We put a little dash or comma between the f and the x, okay? So f prime x equals the limits where h tends towards 0, where f of x plus h minus f of x all over h gives me the gradient. Okay, guys, and that is then how we calculate the gradient of a tangent, which is your derivative. Okay, that's now what we're going to give a few examples of practice to, and it's a really important concept. And whenever you write a calculus exam or a calculus test, finding the gradient of your tangent by first principles, which is by using this formula here, is almost always one of your first questions, and it's always almost worth about 5 marks. So it's really worth getting right, and it's one of those things that you can really make sure that you get those marks on. So let's do those next couple of examples, and you should have a good grasp on your first principles.